In this video, we want to evaluate the indefinite integral of 3 to the ln of x dx. We'll look at two methods to do this. You can pause the video and see if you want to try it, then I'll be back. So the first way we're going to look at this is by doing a substitution, u substitution. So I'm going to let u equal to ln of x. Then du will equal to the derivative of the right side will be 1 over x, and then dx. Solving for dx here, multiply both sides by x, so we have dx is equal to x du. So we'll come back over here then, try to transform this integral into an integral with the variable u instead of x. So this will give me the integral here of 3, and then ln of x will be u, so this will be to the u power here. And then the dx can be replaced by x du. I'll put the x out in front here. So it'll be x du, du will be here. We still need to replace the x. So over here we'll have u equals to ln of x. Using your definition of natural log, this is base e, so x should equal to e to the u. So this integral can be replaced by x is e to the u, so this will be e to the u times 3 to the u. And from here, this looks like a integration by parts problem. So we'll go ahead and do the abbreviated form of the integration by parts. So I'll set up my column here. The d is for derivative, and the I is for integral. So I'm going to put my 3 to u here. This will represent the u expression on the formula for integration by parts, and the e to the u here on the right side will represent the dv. So on the left column we'll take the derivative, on the right column we'll take the integral, and then we'll have a plus, minus, and so on here. Derivative of 3 to the u would be kind of like the exponential e, similar. 3 to the u times the natural log of 3. And on the right column we take the antiderivative with respect to u. It's just going to repeat. Normally we want this thing to go to 0 on the left side so we can complete the procedure, but when we multiply along a row, that's still an integral. So this gen can be written as plus, minus, so it's positive, and then 3 times e to the u. So this will give me 3 to the u times e to the u. And there we go. Second row across, multiply here, and that's going to be an integral. And we're hoping that this will be a simple integral to evaluate. So this then will give me 3 to the u, e to the u. This will be du here. And I also have the ln times the ln of 3. That's a constant though, so I can bring it outside over here. So I put ln of 3 right there. So again, this integral here is equal to this expression right here. But notice this integral is repeated over here. So let's just take it to the other side. And on the right side we'll be left with 3 to the u, e to the u. So I'm going to bring this over. Look at this equation right here. This goes over to the other side, so I add this to both sides. And I get the integral on the left side then, this will be a plus and this will be a 1. So this will be, the coefficient there would be 1 plus ln of 3. And this will be 3 to the u, e to the u, du. And on the other side, on the right side, I still have the 3 to the u, e to the u. I'm going to divide both sides by this. So I'm just going to put an equals here. So this integral right here, which is the original integral over here, same thing, will equal to then 3 to the u, e to the u, divided by 1 plus natural log of 3. And of course you have your constant of integration. So the answer in terms of u is 3 to the u, e to the u, over 1 plus ln of 3. But we've got to go back. Anytime you do a substitution, you still have to go back to the original variable, which was x. So we have this. And so let's go back. 3 to the u. But remember, u is ln of x. So this will be 3. The exponent there is ln of x. And then e to the u, remember over here, that's just x. We wrote it in that form. So this is just x, so I just put times x here. And that's over 1 plus ln of 3. And this is the final answer. X times 3 to the ln of 3 over 1 plus ln of 3 plus a constant. So this is one way to do it. I'm going to use, right here I use the method of integration by parts, and I use the abbreviated form. I've done that before in some of my other videos. So that's one way to do it. Another way to do it, this one I did it this way, so you can see it better. It's easy for me because I have trouble writing with this little pen here. But here it is, 3 to the ln of x dx is equal to, and then I'm using this substitution. Notice here 3 is equal to ln, or 3 is equal to e to the power ln of 3, because this space here is, on this end is e, and this is e. So this expression, just another way of saying that's the same thing as 3. Just rewrote it. So getting back over here then, this is just 3 from that substitution. So this is the same thing as this. So then we come back over here, and all I did here, these are now exponents. Ln of 3 is an exponent, ln of x is an exponent, so laws of exponents allow me to multiply. Alright, so it's like we have x squared to the 3rd power. You can write down your base, multiply the exponents, 3 times 2, that's 6. But once these are multiplied, I can do this, okay? That's 2 times 3, so I can put the 3 there and bring the other one outside. It's still the same. 3 times 2 is still going to be 6, power of 6. So getting back to this then, here I just switched exponents. So the ln x went in here, and the ln of 3 went outside, same thing. And then here, because this base is e, and this is e, laws of exponents tells me that this is the same thing as x. Here it is. And then the exponent then is a 1. So 1 times ln of 3 gives me this. So we get this. Now once you get up to this point, when you integrate or take the antiderivative of x squared, what do? We add 1 to the exponent, so that would be 2 and 1 is 3, and then divide by that. Well, same sort of thing. This is just a number. This is just a number. So to integrate this, we add 1 to ln of 3. Okay, we get this. and then we divide by that. That's your answer, plus your constant of integration. And then we want to simplify it a little bit here. So from here then, laws of exponents again. When I multiply x to the first power times x to the nn of 3 power, it just gives me that. So going from this step to this step is just breaking this down using the laws of exponents. The denominator still hasn't changed, that's still the same. And then from here, based on the setup that we did, substitutions, x to the ln of 3 is just another way of writing 3 to the ln of 3 from the substitutions we did. So this is your answer, plus your constant of integration. The x's came down, ln of 3 plus 1 and the denominator stayed the same, and all we're doing here is saying that x, the ln of 3, based on the substitution we went through, is the same thing as the original integrand, 3 to the ln of 3. Thanks for watching. We'll see you next time.